Good morning. Today I will be starting the electrostatic treater. Previously we have discussed about gun barrel. We have discussed about heater treater. Then today's discussion is about electrostatic treater. We have given basic idea about electricity in previous lecture, but in this lecture we will go into details further. So how it is getting oil and water is getting separated because of electric field, AC field or DC field. We can apply DC current or AC current. Okay, and what is the criteria to apply DC or AC, and how much distance should be there, particle distance, particle size. All this relationship we will try to discuss in this lecture, and we will try to discuss relation between heater treater and electrostatic treater also, because whenever you are using electrostatic treater, heater treater temperature, maximum temperature can be reduced actually. So you will get same separation, but you can reduce temperature. When you are reducing temperature, actually your economics, like fuel economics, lower amount of fuel you are giving, so actually it will be beneficial. So how the whole system works, I will try to discuss in this lecture. Okay. So first go to the heavy oil differences. So 20-degree API or low, it will be called as heavy oil, right? Approximate thumb rule, heavy oil. And if it is 14-degree, then we'll say very heavy. Okay. And if it is coming, let's say 11-degree or less, then we can say this is extra heavy. Okay. So whenever any oil is there 20-degree or less, just you are saying heavy oil. But if you know that viscosity, API gravity is further lower, less than 11 or something, then you can say this is extra heavy oil. Whenever you are moving towards light oil to heavy, very heavy, extra heavy, so actually your separation difficulty will be there, because water and oil, the viscosity density difference will be negligible. When the difference is negligible, particle will not try to move. Okay, particle will be almost static. So in this case, you have to give very long separation time, or you have to use this sort of mechanism, maybe gun barrel sort of mechanism, or heater treater mechanism, electrostatic mechanism. You may have to use emulsion also at the same time. Okay, whenever you are separating emulsion, emulsion breaker, some chemical is there. Already we discussed in previous lectures. So that emulsion breaker, the chemical you have to add, or demulsifier we say, along with all these things. Okay, like heater treater, electrostatic, gravitation settlement, all these things all together you have to apply. Okay, and why you are not using only heater treater or only electrostatic treater? Only one system may not give your desired BSW with economical way. Okay, BSW normal range will be like 0.2 to 2. Okay, BS and W, basic sedimentation and water, that range will be approximately within this range. Okay, but normally we say thumb rule 0.5%. Okay, and if some company is specifying certain amount of like buyer, then you have to maintain that one. And if nothing is given for your calculation purpose for your separate operation system, then 0.5 is okay, the standard thumb rule. Okay, but it should be within this range. It should not be too low, not possible, because 100% removal water and sedimentation is very difficult job. Then you have to keep retention time maybe 1 year, 2 years. So that is also not feasible or practical. So within your feasible limit of retention time, temperature limit, economics of fuel, and maintenance of whole system, BSW 0.2 to 2% will be your normal range. Okay. Difficulty in dehydration, like low oil water density difference, very low difference is there. For example, heavy oil or extra heavy oil, density will be very low, difference will be very low. Okay, so in that case, particle not oil particle, water particle will not try to move. Okay, high crude oil viscosity, if crude oil viscosity very high, again it will not allow water particle to move. Okay, one thing is the density difference high means oil try to move down, very high difference. But if viscosity high of oil, then oil will say I am not allowing to go. Okay, so smaller water droplet size also will be a problem. Okay, you can remember the formula, terminal velocity. Okay, Sg difference dm by mu, right? So, viscosity high means VT low, inversely proportional, specific gravity high, VT will be high, DM high, again VT high. Okay. So, this information you have to remember actually. Okay. And there will be some constant, if you make like VT equal sign, then in that case I think some constant parameter will come, then you can use this parameter DM, mu and Sg. Okay. Normally upper limit of electrostatic heater will be around 300 degree Fahrenheit, upper limit, okay, for heater, not electrostatic, heater. Okay, it will be around 300 degree Fahrenheit. If you are increasing temperature further, what will happen? Lots of low molecular weight hydrocarbon that will also go with your gas. Okay, so it will be shrinkage of oil volume, and you will be losing your money because oil gone to your pipeline or gas pipeline. Okay. So, you should give that limitation of temperature, and for other safety and other aspects also will be controlling this maximum temperature. Okay. So, normally in oil field, crude oil will be producing certain amount of water every time. Okay. Without water getting oil from wellbore is very difficult job. Okay. Some amount of water, some amount of debris, sand and all particle will be there. Okay. That is why you need actually all these mechanism like heater, electrostatic heater, all these mechanism will be required. And this lecture actually I am taking from two papers you can download. Theory of Economics of Electrostatic Heater and Field Implementation in Electrostatic Heating Technology, along with this book also. Okay. So, if you go through this book, so you will get lots of theories, how electrostatic heater working, what are the different formulation. Okay. So, electrostatic heater technology, when you are using electrostatic heater, when you are using, actually controlling factor will be retention time. Okay. So, it will be reducing retention time. You have to give certain retention time so that particle will be moving slowly or it will be colliding each other. So, certain time you have to allow. Okay. And you can add heat also, heater, already you are using heat and changing viscosity, density of crude oil. Water viscosity density will not change much, but crude oil viscosity will change much. Okay. So, heating you are applying and you are changing viscosity and density. Okay. Then you are changing, you are giving AC or DC current. You apply very high voltage, because of voltage the particle will be polarized particle will be colliding each other, they will be creating bigger particle. One bigger particle is there and already change viscosity of crude oil. So, water particle will be trying to settling down. Okay. Crude oil conductivity. So, normally oil will not have any conductivity, but oil will have some ionic material inside oil, okay, contaminant you can say. So, those will be conductive. So, when crude oil is there, ionic material is there, ionic material will be moving each other or it will allow electric ion to flow. Okay. If very high amount of ion is there, it will create short circuit. I have two electrode, okay, and lots of ionic liquid is there. So, actually electric will try to flow from one electrode to another electrode, right. And if you do not have ionic liquid, then oil actually non-conductive. Okay. Now, if you increase temperature, because heater you are using anyway, so you are increasing temperatures, what will happen? It will allow the ionic fluid or ionic particle to move faster. So, it will increase conductivity actually. Okay. So, one graph they have presented like this: temperature and conductivity. So, conductivity unit they have written NS Siemens per meter. N is nano Siemens. Okay, that is actually MHO mho, right? OHM unit of resistance. Okay, so MHO is this conductivity, right? So, oil industry they have accepted this Siemens also one. SIMENS. Okay. So, Siemens also unit of conductivity. So, nano Siemens means divided by 10 to the power 9. Okay. So if you are using temperature that okay, I'll give 50 to 300, they have taken limited temperature within 50 to 300, and conductivity they have written 200 and 1400, so 700 another division you can do, and it is becoming like this. Okay, this is typical curve. Okay, conductivity, how temperature increasing, conductivity increasing, but in some cases very high amount of ionic salts or ionic material is there in oil. So in that case your conductivity can go very high also. Okay, so this is will be very high condition. Typically it will be like 200 300 and ns per meter, but in certain cases it can go further 1000 or more also. So very high conductivity is there, actually it will be creating detrimental for your separation. Okay, you want to ionize water, oil in water, you are separating water, oil, water in oil. Okay, you are taking lots of what oil is there and water particle will be separated like this. Okay, so when you are putting electrodes, your purpose is to remove water. So you have to ionize water, not oil, your main purpose. So if you are ionizing oil because of this extra material, ionic material, so what will happen? Electric field you are applying, so ion will be transferred, your voltage will be dropped, so that voltage will not be useful actually. So it will not give you proper efficiency of system. Electricity used, but water is not getting separated because it's actually short circuiting. Okay, because of ion conduction. Okay, so that will not help. Okay, so if you have low conductivity oil, that is very good, but again you are increasing temperature, some cases ion will be creating, it is the crude oil more conductive, so that will create a low efficiency. Okay, low performance. Okay, so you can remember this typical curve. Okay, with temperature in some cases ion, it can be very high conductive oil. Okay, so what will be doing temperature? Temperature can increases conductivity of crude. Okay, we are concerned about crude oil conductivity. Water is already polarized, right? So it will be giving voltage drop because of conductivity creation. Okay, you create a high conductivity, so voltage will be dropped. But water, they need ion and they want to polarize, they want to move, they want to collide, but instead of doing that you are giving ion to what? Oil actually. Okay, so that is detrimental. So mobility of conductive particle increases, so so voltage drops. Okay, because of temperature increase. Okay, 1 nano n, this unit also you should remember, ns per meter they have written, and this is accepted also, they have written in article. This is called Siemens. Okay, nano Siemens per meter. Okay, and unit will be like 10 to power minus 9 Siemens per meter, because nano term is there. Okay, and this is conductivity, so if it is opposite of resistance. Okay, MHO, mho is your conductivity unit, resistance is opposite of it. So this is also actually opposite of resistance. So it is not giving resistance, rather it is assisting to flow. Ion will be flowing from one electrode to another electrode, so separation performance will dropping. Okay, so normally 50 to 60 hertz electric current if you are giving to 60 hertz electric current if you are giving, then it will be okay. But in case of increasing conductivity, especially AC, okay, AC current will have frequency. DC is not having frequency, right? It is plus and minus. AC is changing polarity continuously, so that's why it will have positive, negative. It will have frequency, but DC will not have frequency actually. Okay, so 50 60 has frequency normally you are giving, that's fine. But your this nano Siemens per meter, if it is increasing let's say 100, okay, ns per meter, so in that case your frequency may have to increase 1600 hertz. Okay, and how to increase the electrical frequency? These days variable frequency drives are there. You may have heard variable frequency drive. Variable frequency drive. This is one electrical instrument. If you give 50-60 hertz, it will convert any frequency you want. You want 2 hertz frequency, 100 hertz frequency, 200, so it will convert. Okay. So using variable frequency drive, you can change electrical frequency. Okay. Variable frequency drive, variable. Some more terms are there. Just you can Google and you can find some more terms of variable frequency drive, variable VFD, VSD, variable speed drive. So some other terms also there. Okay. And step up, let's say if you give 220 volt, it will not work. We already have calculated, right? So in that case, you have to use transformer, and you have to use step up transformer. Okay. Use step up transformer to increase voltage. Okay, when you are increasing voltage, power is fixed, your current will be going down, right? So how can I say that? P equals V into I, power, voltage, current. Okay. So if you are changing voltage and power fixed, that means current is dropping. Okay. Whenever we are using term step up, step down, we are not using for current, we are using for voltage only. Okay. So they need voltage. If you are changing current, actually amount of flow separation will be changing. Okay. Voltage means you are creating field, gradient. Two electrodes are there, plus, minus, you are creating gradient using voltage. Current means how much ion is moving. Okay. Current, how many ions are moving. But voltage will be giving how much pressure difference you are creating. Okay. So voltage will be pushing your ions. Okay. So 10 ions, 20 ions, 30 ions, whatever number of ions are going. So voltage will be pushing them. Okay. So current is related to ion. So voltage means it is gradient of pressure. Like you can assume the water pressure. So very high pressure, high flow rate you can create. Okay. And velocity and current will be like flow rate. Current will be flow rate. Okay. So sometimes they create electrical analogy. Electrical analogy means like voltage will be like pressure difference, current will be flow rate, that way. Okay. And resistance means frictional pressure drop in piping flow you have. So that is resistance. Okay. So conductivity increase 100 nanosecond. Okay. Conductivity increases with temperature of oil depending on. Okay, solid. Okay, solid present, like if any ionic liquid, ionic particle is there, ionic solid or any other ionic particle is there in oil, so that will create ionization of oil. Okay, oil itself is not a ionized fluid, right? Okay. So three type of primary electrostatic forces. Three types of primary electrostatic forces. Static forces. Okay. So one is that dipolar attraction. Two is your electrophoresis. And third is dielectrophoresis. Dielectro, TRO. Okay. So dipolar attraction actually is the electrostatic attraction force between opposite charged ends of water droplet. Let's say I have one electrode plus, I have minus. Okay. Then I have water particle. Okay, it will create bipole. One will be minus, one will be plus, and if you are attracting from both sides, so it will be distorted actually. Okay. Normally water particle will be circular in shape, raindrop also falling circular in shape. So what is the reason? You know that surface tension actually. So surface tension will try to create lower surface area, lowest surface area possible. Okay. So, when you are creating lowest surface area, the spherical shape will create the lowest surface area. So, whenever water particle is there somewhere, if you do not have any extra other forces, then it will try to create circular shape, spherical shape. Okay. Now, in this case using electricity, you are trying to distort the shape. Okay. Instead of they are taking smallest area, surface area. So, to break that smaller surface area, you are creating high voltage and you are distorting it. When you are distorting, possibility is that other particle will be touching and your break, that emulsifying agent on the coating the water droplet, it can break also. So, when it is breaking, maybe two particles will be joining quickly. Okay. So, there is a purpose. So, dipolar attraction is that the electrostatic attraction force between opposite charge ends of water droplet. Okay. So, one particle is here, another particle is here. Okay. So, plus minus, plus will be attracting the minus side. Okay. So, water will create a bipolar droplet. So, single pole not possible. Okay. So, it must be bipolar, plus minus must be there, right? Only plus and only minus are not possible. Okay. So, dielectrophoresis, this is actually when you are applying constant electric field. Okay. So, you are creating constant electric field plus minus, okay, and is trying to move, let us say, towards minus electrode, okay, negative electrode. So, this is called electrophoresis, constant electric field you have applied, and dielectrophoresis actually if electric field is variable. So, that is called dielectrophoresis. Okay. And is very high voltage you have applied here. Okay. So, because of very high voltage, actually the electric field is variable inside the system, but you can create multiple electrode and you can create uniform electric field inside the system. Okay. You can create uniform electric field or variable electric field because of the, okay. Now, we will discuss how this AC and DC is getting applied. So, when you are applying AC, actually particle will be resonating. So, sometime you are giving one electrode plus, after few fraction of second it will be minus. So, plus minus continuously doing, and particle also changing, let us say particle vibrating, right. When it is vibrating, one particle is there, another particle is there, they will try to collide. Okay. So, particle not trying to move to one electrode, rather locally they are trying to collide. So, that means you should have lots of particle nearby. You have lots of particle nearby, then particle collision rate will be higher in AC current. So, in that case, if you have higher amount of water, say lower section of separator, higher amount of water, in that case you can use AC current and you can create collision more. You will create bigger particle, it will be settling further down, then from bottom you take out. Okay. But if you have DC, okay, DC voltage you are applying, let us say high bond separator and one layer is here, okay, and another layer is here. So, lower portion water, number of water molecule will be higher, water droplet will be higher. So, there you apply AC voltage, give resonance, particle collision will be there, it will be distorting, particle collision will be there, that rupturing possible, that surface coating agent, whatever emulsifying agent is there already. Okay. If you have already removed the emulsifying part, fine. If it still something is there, it is coating, when they are colliding, it is possible that they will be fusing together, they will make bigger particle, and Vt proportional to dm square, just simple you can remember, right. So, dm square, right. So, you are not changing oil viscosity or anything, you are just changing particle size, you are promoting collision, changing particle size, and particle automatically slide. Okay. And when if you are assisting with heater treater, then heater treater is changing your oil viscosity. Okay. So, DC current where water cut is more. Okay. So, AC where more water cut is there. Okay. So, because particle will be nearby, resonating, colliding, making bigger particles, separating, done. But DC, when you are giving DC current, what is happening? DC current where water particle are sparsely distributed, okay, and you are giving two electrodes, say here. So, let us say one plus, one minus. So, plus will be attracting the minus end, minus will be attracting the plus end. Okay. So, very high voltage you apply. So, slowly the particle will try to move towards electrodes. Okay. So, let us say one particle A moved towards this electrode, touched the electrode, it got charged. So, when it got charged, actually again they will be having a repulsive force. Okay, plus they will be having repulsive. So, they will try to move in opposite direction again. So, one particle moving towards plus electrode got charged, again they will have repulsive force, they will try to move other direction. Okay. When they are moving, trying to move, they will, possibility is that they will collide with other particle also, because many particles try to move, some trying to move this some other direction. So, collision rate will be there. So, actual particle motion will be there. Okay. So, in that case, actually low water cut system if you have, then it will be effective, more effective. Okay. So, low water cut. Okay. So, how to create low water cut, high water cut? So, separator upper layer will have low water cut, low amount of water, because water is getting settled. Okay. Bottom part water amount higher. So, you can create higher water cut there. Okay. So, in that way you can separate. Okay. I have more information, I will explain. Yeah, electrophoresis actually horizontal, moves water droplet horizontally between electrodes in a uniform DC field. Uniform. Okay. Uniform DC field you created, plus minus, and droplets moving in one direction. Okay. Again it will be moving opposite direction also. Okay. But dielectrophoresis actually weakest one. You are trying to mix both dipole attraction and electrophoresis. Okay. So, weakest of the three electrostatic forces is approximately half strength of the dipole attraction forces. Polarized water droplets move in a non-uniform electrostatic field, okay, you are creating, then you are separating.